See another few questions from the previous competitive exams from superposition theorem. So here I wrote these problems from the superposition theorem. Later we will discuss Thevenin's and Norton's theorems. So one problem is given like this: in a linear network, the superposition theorem can be applied to calculate. So in a linear network, the superposition theorem can be applied to calculate. One option is there, voltage and power. So power calculations is not possible using superposition theorem, because superposition theorem explains the total response is equal to sum of individual response. So total power is equal to sum of individual power. This statement is not suitable for power determination purpose. So power calculation purpose, superposition theorem is not suitable. So here also power is there, this is also wrong. And now in this case, voltage and current power, so power is not possible, so this is also wrong. Now the linear network, the superposition theorem can be applied to calculate voltage and current. So now the option C is correct. So from the limitations, there I explained clearly limitations. It is not suitable for non-linear elements, and it is not suitable to determine power measurements. And another is, it is not suitable for single voltage source, single sources networks. So the network requires more than the one source, then the superposition theorem is applicable. So according to the given option, C option is correct. And one more problem is given like this: in a linear network is excited by the two voltage sources. Those sources are V1 and V2. Two sources are connected. If V1 is activated, then the power dissipation in the resistor R is 25 watts. So then I am writing here, individual response P1 is 25 watts. 25 watts. If V1 is activated means V2 should be eliminated here. V2 is 0. And if V2 is activated, second source is activated, first source is disconnected. So first source is eliminated. If V2 is activated, then the power dissipation in the resistor R is 16 watts. So right here P2 is 16 watts. 16 watts. If both the sources are activated, now V1 and V2 are activated. So in last video there clearly I explained, one linear network is connected with V1 and V2 source, and one source load branch is resistor R. So V1 is activated, power P1, V2 is activated, power P2, that is P1 is 25 watts and P2 is 16 watts. If both the sources are activated, then the power is, so don't apply superposition theorem here. According to the superposition theorem, total response is equal to sum of individual responses, then it has to become like this, 25 plus 16. But superposition theorem is not suitable to determine the power. Superposition theorem is not suitable to determine the power. So from the current equation there we wrote one standard power equation. The power equation is total power is equal to square root of P1 plus or minus square root of P2 whole square. This equation is there. This is for power measurement purpose. But superposition theorem is applicable for current and voltage parameters purpose. Like total current is equal to, we can write sum of individual currents, and total voltage equal to sum of individual voltages. But don't write total power is sum of individual powers. So power determination purpose, superposition theorem is not applicable. So from the current and voltage relations, there we wrote one standard equation. If the individual powers are given like this, then the total power is square root of P1 plus or minus square root of P2 whole square. This is not superposition theorem. Superposition theorem is V1 plus V2 is superposition theorem. I1 plus I2 is superposition theorem. But here square root of plus or minus square root of P2 whole square is there. This is not comes under superposition theorem. But this equation is derived from the superposition theorem using current and voltage parameters. So the total power is equal to, this formula is there, just apply this one here. So root 25 plus or minus I am taking now, root 25 becomes here 5 watts plus or minus root 16. Root 16 becomes here 4 whole square. If you want to take maximum value means don't consider, both should be positive values, then it becomes 9 square. 9 square is, so because 5 plus 4, 9, and this becomes 81 watts. This gives the maximum power. And if you want to take a minimum, perform the subtraction. The subtraction becomes here 5 minus 4. 5 minus 4 is 1 square, that becomes 1 watts. Then the range of the total power is 1 watts to 81 watts. This is the range of the power. Now if you want to write here only the power is means always we have to prefer maximum. So maximum is 81 watts. Sometimes the expected question is what is the range of the total power. The range of the total power is expected is in between 1 watts to 18 watts. That is depends on the current direction through that resistor R. If the both directions are same direction, then we have to perform addition operation. If the both directions are opposite direction, then we have to perform subtraction operation. From that, here we can write either plus or minus operation. So range is 1 watts to 81 watts, and the question is here what is the total power. Then write here maximum power is 81 watts. Depends on the options, you can select any one here. Now this is another question from the superposition theorem. And one more question is like this. So here one network is connected with single two sources. One is voltage source, another is a current source. Those two sources are ideal sources, right? And those are connected in parallel combination. And if you want to apply superposition theorem for this network, so initially I am applying voltage source. If the voltage source is connected, current source is eliminated now. Current source acts as a open circuit. So if it is open circuited, here resistor 2 ohms is connected and voltage source is 10 ohms is connected. 10 ohms is directly connected to the 2 ohms resistor, then the current through the 2 ohms resistor is 10 by 2, that becomes 5 amps. So current through the 2 ohms resistor is 5 amps due to one source. And due to second source, here resistor connected is as is and current source is connected now. Current source is activated but voltage source is eliminated here. So internal resistance of the voltage source is 0, then the voltage source acts as a short circuit. Whenever one circuit is short circuited like this, parallel resistance is eliminated temporarily because this total current is flows through this path. The current is here 2 amperes. But according to the given problem, we want current through this branch I double dash, this becomes here 0. So with current source, current through the resistance 2 ohms resistor is 0 amps. Then the total current I is equal to I dash plus I double dash. This becomes now 5 amps. 5 amps. Due to current source, the complete current is flows through the short circuit path and current through the resistor is 0. Then it gives you 0. Then the total response is equal to sum of individual responses. Then it becomes here 5 amps. So from the given question, this I is 5 amps. Here I explained using superposition theorem, and in first introduction class basics of network chapter, there I explained the same problem. The find the current through branch I means here voltage is connected across the resistor. Directly here available voltage is 10 ohms is there. Then the current through this one is 10 by 2 directly, which gives the 5 amperes. So 5 amps current is flows through the 2 ohms resistor. This is from the basics I explained there. But here I am explaining the same problem with superposition. With superposition means at a time only one source is applicable. If the superposition theorem is valid for any network, that network is a linear network. If the superposition theorem is not valid for any one given network, that network is a non-linear network, because superposition theorem is applicable for only linear networks, not applicable for non-linear networks. So if the superposition theorem is not valid for any network, that network should be non-linear network. So remember that point here. So these are the solutions of the given problems. So all these problems are previous competitive exams question. This is previous ecet question, and this is previous gate question, and this is previous competitive exams question like DRDO and sub-engineer questions here. These are the simple questions. Just we have to apply superposition theorem principle here to find the unknown parameters. So please note down the solutions of the given problems. From the superposition theorem, some other previous competitive exams questions. So in that one question is given like this. Here this network is connected with the two independent sources. One is voltage source, another is current source, and another is here dependent source is there. So now we have to discuss how to apply superposition theorem with the dependent source representation. And if the network consists of minimum one independent source here, so now it is connected with two independent sources. So according to the superposition theorem, total response is equal to sum of individual responses. So individual response is nothing but the response of the circuit due to one independent source. One independent source, other independent sources are eliminated. So here we have to consider one independent source should be in active position, other should be eliminated, and don't eliminate the dependent sources. So dependent sources are not eliminated. So dependent sources are depends on this voltage value, that's it. If the voltage value is 0, then that becomes 0. So now we have to apply superposition theorem for the given network. So find Vx here from the superposition theorem. See, just observe the network. In this network, Vx is given here. Vx is voltage across 1 ohm resistor. Here we want here. Voltage across 1 ohm resistor is Vx. So now we have to find out using superposition theorem. See, to find Vx, another simple technique is there, that is nodal analysis. Using nodal analysis, we can write directly Vx. But here we are discussing superposition theorem and how to apply the superposition theorem for different networks. That purpose, now here I am applying to find Vx purpose superposition theorem. So according to the theorem, at a time only one source is activated, remaining sources are eliminated. So one independent source is activated, remaining sources are eliminated. So initially I am applying here voltage source. Voltage source is connected. This resistor value is 1 ohm and here the symbol is minus plus is there. This is Vx. This voltage is 1 voltage source. Current source internal resistance is infinity, it acts as a open circuit. Now the current source is open circuited, this resistor connected as it is, and dependent source. Don't remove the dependent source. Dependent source should be as it is, so keep it as it is here. So this value is Vx by 2. This dependent source value depends on the completely this voltage across this 1 ohm resistor. So that value is Vx by 2. This resistor value is 1 ohm. Then from this here we want Vx. So to find the Vx, just go through the circuit. So if the current source is eliminated, this is acts as a one single loop circuit. This acts as a one single loop circuit. Just apply loop circuit analysis here. So current through this is I am assuming I. Current through the circuit is I am assuming I. So apply loop here. So here I am applying voltage across 1 ohm resistor I plus this is voltage source, dependent source, enters with positive terminal symbol. So Vx by 2 and here it enters here minus 1 and again enters with plus 2. So plus Vx is equal to 0 because voltage across 1 ohm resistor is voltage across 1 ohm resistor Vx is equal to here. Vx is equal to voltage across 1 ohm resistor. Now assumed current is in this direction. In this direction, that is 1 into I. Resistance into I. So directly we can take one standard representation is Vx is equal to I in this. Vx is equal to I. So now in this equation replace I is equal to Vx. So I am replacing here Vx plus Vx by 2 plus Vx is equal to 1. So this minus 1 I am writing this side now. Then simplify this. Vx and Vx to Vx by 2, 2.5 Vx. So then directly which gives the Vx is equal to 1 by 2.5. So 1 by 2.5. So this is Vx value. This Vx is I am assuming Vx dash. Vx dash because this is due to first source. So I am assuming here this is Vx dash, here Vx dash, here everything is right with Vx dash. Then directly which gives the Vx dash is equal to 1 by 2.5 volts. 1 by 2.5 volts due to one source, that is voltage source. Similarly, apply second source here. Second source is current source. Current source is applied and the current source is connected, voltage source is eliminated. The internal resistance of the voltage source is 0. So voltage source acts as a short circuit. Here voltage source is short circuited and here current source is connected as it is. Then the remaining network is as it is here. Don't change the remaining network. Only independent sources are eliminated. One independent source is activated. That independent source is current source. That value is 1 amps here. And the remaining resistor values are 1 ohm and minus and plus is there. This is Vx. Now this is acts as a voltage source, Vx by 2. Don't remove dependent sources. We have to remove only independent sources. So independent source is eliminated. This independent source is voltage source, so it is short circuited. Then find out Vx here. See, to find the Vx here, say if it is short circuited, the complete voltage across this path is Vx, because only one resistor is there, and here it is considered with the minus symbol. So otherwise I am assuming here this is V1. Initially I am assuming V1. I am applying nodal analysis here. So voltage across this one is V1 by 1. Voltage across this branch, this total branch is V1 by 1, because this is acts as a ground terminal. Then the current through this is already mentioned -1, because the current is incoming current. Then plus current through this one V1 minus, here plus is there, so Vx by 2 by 1 is equal to 0. Just I wrote here nodal analysis at this node. So 3 branches are connected, one branch is 1 ampere, current source is incoming current, so -1. Current through this branch is V1 by 1, and current through this branch is V1 minus Vx by 2 by 1. So I am applying a nodal analysis. And according to the given problem, so here V1 is there, V1 is nothing but voltage across these 2 points, plus and minus is required. So this is acts as higher potential. But here this branch is there, here parallel cases voltage should be same. So according to this given problem, this branch is Vx is given, but symbols are opposite, symbol is there. So that's why I am writing V1 is equal to minus Vx according to the given problem. V1 is equal to minus Vx. Then, so this is due to second source, I am assuming V double dash, Vx double dash. So write like this. So V1 is equal to minus Vx double dash. Then substitute the complete equation with this one, minus Vx double dash, -1 write as it is, and here minus Vx double dash and minus Vx double dash by 2 is equal to 0. Then simplify this. So after simplification, minus Vx minus 2Vx and minus 2Vx by 2. So again it gives the minus 2.5 Vx double dash by 2 is equal to, write this one is this side. Then directly which gives the, sorry, Vx double dash, Vx double dash is equal to, so if you take this side, minus 1 by 2.5, minus 1 by 2.5 volts. So due to one source here 1 by 2.5 volts, and due to second source here minus 1 by 2.5 volts, then according to the superposition theorem, total response is equal to sum of individual responses. So if you apply these two, 1 by 2.5, 1 by 2.5, minus 1 by 2.5, then directly which gives how much here? 0 volts. So according to the given problem, so Vx voltage is nothing but voltage across this point is how much here? 0 volts. So directly which gives the Vx value is 0 volts according to the given problem. So now here applied superposition theorem. So from the superposition theorem analysis, we have to apply at a time only one source. One source is activated, remaining sources are eliminated. So initially voltage source is activated, current source is open circuited. Then it gives the Vx dash. Vx dash is equal to 1 by 2.5 volts. So to find the Vx dash purpose, here I applied KVL, Kirchhoff voltage law here. And similarly, later I applied current source. Current source is activated and voltage sources are eliminated. If the current source is activated, voltage sources are eliminated, voltage source acts as a short circuit, then it gives the Vx double dash. That Vx double dash is equal to minus 1.25 volts. So from the superposition theorem, total response is equal to sum of individual responses. So if we apply the individual responses directly, which gives the 0 volts. So now the answer is here 0 volts from this given problem. So Vx is 0 volts. Now another important problem is that this is also on previous competitive exam question. The question is like this, one source, Vs source is connected, resistors are connected, then voltage across R4 resistor is V4 is there. Voltage across R4 is V4. So that means voltage across R4 V4 is given here. If Vs is increased by 10%, in this case if Vs is increased by 10%, then variations of the power in R4 resistor is, here how much variations are in power calculation part. So here superposition theorem is not required because the complete network is consists only one independent source. Superposition theorem, to apply the superposition theorem, minimum it requires two independent sources. So more than the one independent sources are compulsory, but the network has only one independent source is there. Here superposition theorem is not required. But to find the power in R4 resistor with variation of the input purpose, here we have to apply homogeneity theorem. Homogeneity theorem explains if any constant multiplies with the input, same constant multiplies with the output. If any constant multiplies with the input, same constant is multiplies with the output. So to find that purpose, initially I am finding with Vs source V4 voltage. V4 is nothing but voltage across R4 resistor. So to find that purpose here I am assuming current through this one is I. Current through R4 resistor is just I am assuming I. So due to Vs source, here current is I is there, then we can write I into R4. I into R4. Otherwise V4 is directly given. Then write power equation. Power. First condition I am writing now. Due to Vs source. Due to Vs source, power is equal to 3 representations are there. V into I, V square by R, or otherwise we can take I square into R. So now here I am taking V4 is given. That's why I am writing power is equal to V4 square by R4. So with Vs source, here some voltage is there. Due to that voltage, the power consumed, power dissipation in the resistor R4 is V4 square by R4. This is P1. Now Vs is increased by 10% now. Vs is increased by 10%. If the Vs is increased by 10%, then the Vs value is Vs dash value is 1.1 Vs. Vs is increased by 10%. 10% increases means this Vs value multiplies with 1.1. Suppose initially 4 volts is there. Now 10% is increased. 10% is increases, then what is the power here we have to find out. So to find that analysis purpose, 10% is increases means the actual value multiplies with 1.1. Then with this increment here the response V4 is also increases. So then V4 becomes here voltage across R4. This I am writing V4 dash. V4 dash. So V4 dash is current is also increases. The current is I dash into R4. Then I am finding power now. Power is P2. So if the voltage source is 10% is increases, here this voltage also increases by 10%. So the 10% increase means now it becomes 1.1 V4 whole square by R. 1.1 V4 whole square by R. See, if any constant multiplies with input, same constant is multiplies with the output. Initially here Vs source, then the voltage across R4 resistor is V4. Now Vs is increased by 10%. 10% means now here 1.1 into Vs. Then this response is also increased by 10%. That response becomes now 1.1 V4. So the increment response is voltage and current. These two parameters we have to take. Don't take power directly. Don't write power 1.1 into P1. Voltage or current. These two parameters are directly proportional. Like voltage, input voltage is increases, output voltage also increases. If the input voltage is increases, output current is increases with same factor. If the input is multiplied with K, output voltage is also multiplied with K factor. If the input is multiplied with K, output current is also multiplied with K factor. But here the question is power is there. That's why initially I am finding voltage and later we have to find out power. So due to this 10% increment, here 10% voltage also increases, then the value becomes 1.1 V4. Then the power formula is voltage square by resistance. So voltage square by resistance is how much here? R4. Then perform the square, P2 is equal to 1.1 whole square is 1.21. 1.1 whole square is 1.1 into V4 square by R4. V4 square by R4. So here V4 square by R4 is just now we assumed this is P1. So V4 square by R4 is P1. Just replace the complete term with P1 here. So directly which gives the 1.21 into P1. So now this relation is important. So due to Vs source here power is P1. Due to Vs source power dissipation at resistor R4 is P1. And if the source is increased by 10%, the power dissipation at resistor R4 is 1.21 into P1. So this becomes now 1.21 into P1. P1 is nothing but the power dissipation due to Vs source. And 1.21 is the power dissipation due to 1.1 Vs. So 10% increment in the source, then automatically power is increased by 1.21 times. Power is increased by 1.21 times. Voltage is increased by 1.1. Voltage is increased by 1.1 times, but power is increased by 1.21 times. So these problems also comes under superposition theorem and homogeneity theorem, and these problems also important because all these questions are collected from the previous competitive exams questions. So please note down the solutions of the given problems.
Thank you very much guys for watching all the videos. So far what we have completed, let's discuss about it now. Over the screen you can watch SAIMEDHA.in app. If you open the app guys, you are going to see there. Let's talk about the store now. In some other branch, let's open a EEE branch guys. In the EEE branch you can see the content. In the content engineering, in the engineering we have electrical circuit, 75 videos there. In that machine nodal analysis, if you open, you can see there we are having around 11 lectures guys that we have completed. Then practice set 1, practice set 2 with solutions, questions with solutions, practice set 3, questions with solution, previous ecet questions with solutions, and at last we have what machine and nodal analysis practice sets. So what we have covered guys, we have completed all the basic to advanced level video lectures. Then we have completed the practice set 1, set 2, set 3. Each set is going to have around 20 to 100 questions there guys, based upon the topic marks. It is going to be there in the not only in ecet but also in the government jobs and PSUs. And at last you have there an online test examination also, in order to check the time management what you need to utilize in the competitive examinations. So this is so far we have completed guys. Now you can watch over the videos. It can be utilized for, it is useful for not only the ecet examination but also for DRDO, sub engineer, assistant engineer, Telangana State Public Service Commission, Andhra Pradesh Public Service Commission, BHEL, NTPC, IOCL, Staff Selection Commission, JEE. I remind guys for EC, EEE and civil, this SSC, JEE will be there every year twice. So make sure you utilize all the video lectures to prepare for this examination also. And everyone knows about the Railway Recruitment Board, Junior Engineer, and as well as ISRO guys. If you people are interested to watch all the full length videos in the SAIMEDHA.in app, make sure you save this number. This is in charge sir Shashikant Valmiki sir number guys, 98486-92598. Give him a missed call, give him a call guys for any details, for any updates. Every single day we are updating the videos, material, and as well as what a competitive level examination practice set papers also. Thank you very much guys. I wish that you have watched all the videos. If you haven't watched so far, go and refer all the videos guys. Thank you very much. This is Mohammad Inzamam signing off.